Hello and welcome to yet another riveting installment of the Algebra 2 videos. This is Unit 2 and this is Section 6. And this is a very important section about factoring polynomials, specifically talking about the difference of squares. Okay, so our objectives today, we want to identify a monomial that is a specific square and find its square root. We want to determine if a polynomial is factorable by recognizing that it is a difference of two squares, and if so, applying the identity. So the first thing I want to do is talk about this concept of using a geometric model to factor, and we want to create a rectangular representation here. Okay, we have this polynomial x squared minus 4. So we have an x squared tile and then minus 4 other tiles. Okay, fortunately we can't create a rectangle here. So what we have to do is we have to add a positive and negative x that would add to 0 to hopefully give us the square rectangle that we need when we're doing this. Okay, so we realize that we have to add in a couple of these in order to get that. And so you have x squared minus 4. Now negative x plus x, those add to 0. Okay, and then if we fill in our factors here, we get that we get x plus 2, and then here we get x minus 2. So what we realize here is that if we wanted to factor the polynomial x squared minus 4, then we could factor that into x plus 2 times x minus 2. Now notice here that this is what we call a difference of squares, okay? This is really me saying x squared minus 2 squared, okay? 4 is a perfect square, okay? And so what we can do is we know to factor that automatically, and we'll kind of more or less talk about how this all works. But notice that these are opposite binomials, okay? These are opposite binomials, all right? And you're probably wondering, okay, well, how does this work? Why do we not have that x term that's in the middle, okay? And so what we can do, if we wanted to verify, why this works, verify that this is the factored form of this polynomial, okay, then we would use the FOIL method, okay? And that means that we're going to take the first, okay, which means we're going to take x times x, so x times x, which gives us x squared. Okay, we're going to take the outside, okay, which means I'm going to take x times 2, so 2 times x, and that's going to equal 2x, okay. We're going to take the inside, okay, which means I'm going to take negative 2 times x, so we're going to take negative 2 times x, which gives us negative 2x, and then we're going to take the last, which is just going to be negative 2 times 2, all right, which is going to give us negative 4. So when we add all of these terms up, okay, we're going to get x squared plus 2x, and then minus 2x, and then minus 4. So what happens here is that these two terms, negative 2x minus 2x, this adds to 0. Okay, so this adds to 0, and so as a result, we get this as our polynomial x squared minus 4, which is what we started with. Okay, so because these two things are the same, we're good. Okay, then this is the correct factored form, okay, of this polynomial. All right, so let's move on. Okay, and we can sit here and we can talk about using the x method, okay, where we want to factor this right here, x squared minus 16. So we did we did the geometric model, and let's go ahead and just do the x method here. And so let's identify what our a, b, and c are. Now let me rewrite this real quick because it's kind of hard to identify the b value when you have something like this. So if I rewrite this as x squared plus 0x and then minus 16, okay, then what we get is we get this polynomial where we can identify our a value, our b value, and our c value. Okay, so then if we take a times c, okay, that's just going to give us negative 16. Okay, so negative 16, and then our b value is 0. all right? So I want to find two numbers, okay, where they multiply to negative 16, but they add to 0. And those two numbers are negative 4x, I'm sorry, just negative 4, and then positive 4. Okay, so what I'm going to do is I'm going to split this middle term up, and I'm going to rewrite this as x squared, and then minus 4x, and then plus 4x, and then minus 16. Okay, and what I want to do now is double group this and group this, you know, any way we can, and so you know, do the double grouping. And right when I look at this group here, I know I can factor out an x. So if I factor out an x, then I'm left with just an x minus 4, okay? And then over here, if I look at this group, I can factor out a positive 4. So if I factor out, and let me make this red, okay, if I factor out a positive 4, then we are left with just an x minus 4, all right? So because I have a common x minus 4, okay, I can factor out that common binomial, and we're left with x minus 4 times x plus 4, okay? The other thing that we can realize is that, you know, if we have x squared minus 16, you know, notice that 16 is a perfect square. I could rewrite that as x squared minus 4 squared, okay? And notice that when I factor that, okay, and I got these are opposite binomials. Opposites. All right? And we also call these conjugates, okay? And we'll get to that. We call these conjugates, okay? All right, so that's all I have for that page. Let's move on to the next one. Okay, let's take a look at a couple of these problems here, and we want to factoring a difference of perfect squares. Now, what I'm realizing here is that if I have, you know, this one right here, x squared minus 25, I'm going to rewrite that as x squared minus 5 squared, okay? And what I've realized is that every time I have something squared minus something else squared, then I get that their factors are just the are conjugates, which they're opposite binomials. So if I rewrite this as x plus 5 times x minus 5, okay, then that's it. I'm done. That's all I need to do, okay? And so, but that's the hard part, is just recognizing that you have x squared minus 25 and rewriting that as x squared minus 5 squared. Okay, and you could even rewrite this and ask yourself that question that we had that was, okay, if I have x squared plus 0x minus 25, okay, what two numbers add to 0, so add to 0, but multiply, okay, to negative 25? All right, and so that would be negative 5 and positive 5, okay? Those two numbers will add to 0, but they multiply to negative 25, and that's how I factored it. Okay, over here. All right, and that's all you really need to do, okay? But what if you have something like this? What if you've got, say, something like 4x squared minus 9? Now, here's the problem, is that you have this leading coefficient of 4 out here. Now, what I have, and let me rewrite this. So if I rewrite this and think about this as like, well, what if I wrote this as the quantity 2x squared, or I'm sorry, 2x quantity squared minus 3 squared. Okay, and what I want you to see here is that you have a quantity squared minus another quantity squared. Okay, and if I have 2x quantity squared, then all I'm really doing is, you know, I'm just taking 2x times 2x, which ends up giving me 4x squared. Okay, so I can rewrite this as 2x squared, and so then what I would do if I recognize that, then I just factor that as just 2x plus 3 times 2x minus 3. Okay, and remember, if you're wondering, you know, okay, did I factor this correctly? Then remultiply it out. Okay, so if I FOIL it, then I'm going to get 2x quantity squared. Okay, I'm going to do 2x times negative 3, so minus 3 times 2x, and then let's do plus 3 times 2x, and then let's do minus 9. So negative 3 times negative 3. Let me write that out. And then minus 3 times 3. So what we get 2x squared is going to give me 2 squared, which is 4, and then x squared, which is just x squared. This is going to give me minus 6x. This is going to give me positive 6x. And then negative 3 times 3, that's going to give me negative 9. Now what we realize is that the negative 6 and the positive 6, those add to 0, so they cancel out. And then we're left with 4x squared minus 9, okay? And so we have the same thing that we started with, okay? And what I want you guys to realize is that, you know, if you have something squared minus something else squared, then you do that, the sum of the two times the difference of the two. You do the conjugates of each other, okay? So let's take a look at something else. You know, what I notice here about this form is that you have 9x squared minus 16. So if I were to rewrite this, okay, because it looks to me like it's a difference of squares. What I notice is that I take 9x squared, I can rewrite that as 3x quantity squared. Okay, the reason is that if I take 3x times 3x, I get 3 times 3, which is 9, and then x squared, okay? So, you know, notice that 9 is a perfect square. You know, 3 times 3 gives me 9, and then x squared, okay? And then minus 16. I can rewrite that as minus the quantity 4 squared, okay? So if I were to sit here and if I were to, you know, factor this, then I would take my first term, which is 3x, and then do plus 4, and then times 3x minus 4. And the thing that's tipping me off about this is that I don't have any middle term here, okay? There is no term with just an x, okay? I either have x squared or I don't have an x, okay? So that's usually what tips me off that you know, that I can use this idea of conjugates and using the opposites to factor it, okay? And you can go through the other methods if you want, you know, but there's just, you know, let's just take a, you know, either way. I don't care how you do it, just get it right, okay? On this one, you know, let's talk about the sum of perfect squares, okay? And so let's ask the question, what two numbers, so I want two numbers that add to 0 but multiply to 9, okay? And the answer to that is that there are none, okay? There are none that do this. So if you have a plus symbol here, then this doesn't work, okay? This is not factorable, okay? And so it's a prime polynomial, actually. And so that's the idea. You know, if you have the plus symbol in there, it's not going to work, okay? You know, think of two numbers that add to 0 and multiply to 9. If you want to try that on your own, you can do that. I'll wait for you to do that, and you can just come tell me when you want to. But if I ask the question, you know, two numbers that add to 0, all right, and multiply to negative 9, okay, then I can say that that would be negative 3 and positive 3, okay? Those two numbers will add to 0, but they will also multiply to negative 9. Now, the thing about it over here is that in order for two numbers to add to 0, they have to be opposites, okay? But in order for them to multiply to 9, they have to be either the same sign. They have to be the same sign. They can't be opposite signs. So we have kind of a conflict of interest. You can't do it, okay? So therefore, you know, you just get negative 3 and 3. And so x squared minus 9 just becomes x minus 3 times x plus 3, okay? And that's it, all right? So then, you know, we come up with this idea here. And I've been kind of talking about this, and I've done some of these examples where this is the definition of difference of squares. If you have some value a squared minus some value b squared, then you get a minus b times a plus b, okay, as your factored form, okay? And you can really apply this to anything, okay? So, and so I had kind of gone through these examples with you on the other page. You know, you can, talk about, you can think about this question and go through that. But the reality is that if you take the square root of both of these numbers, they come out to nice even numbers, okay? And the thing about the part here, and I will say this about this one over here. You know, when you have 4x squared, this is the hard part, to understand that these actually come out to the values of 2 and x, okay? When you take 4x and you know, if you take the square root of those, okay, square root of 4x squared, I can split that up into the product of square roots. I can take the square root of 4 and multiply it by the square root of x squared, okay? And as a result, okay, the square root of 4 is just going to give me 2, and square root of x squared is just going to give me x, okay? And so I know that if I take the quantity 2x and square it, okay, that's just going to give me 4x squared, all right? Goes both ways, all right? So that's the idea, all right? Okay, and this process still does apply to, you know, factoring a difference of squares when you have powers that are greater than 2, okay? So I do want to look at something like 121x to the 6 minus 81. This is factorable, okay? It may not seem that way, but let's just take a look at it. And what I want to do, and what we know, is the difference of squares formula. A squared minus b squared is going to give us a minus b times a plus b, all right? So what I want to do is I want to figure out, okay, well, what is this, okay? What can I do here? So what I want to do is I want to take 121 times x to the 6, and I want to take the square root of that, okay? So if I take the square root of 121, that's just going to give me 11, okay? Well, hold on. Before I do that, I'm going to multiply this by the square root of x to the 6th, okay? And so what I end up getting is I get 120, square root of 121 is 11. Square root of x to the 6 is going to be x cubed, okay? So this is my a value, okay? And then my b value, you know, if you take the square root of 81, that's just going to give you 9, okay? And that's my b value, okay? So what I want to say here is that I can rewrite this as the quantity 11x cubed quantity squared minus the quantity 9 squared, okay? And because I have both of those quantities squared, all right, and I have the difference of them, then I can factor them using the difference of squares. And so I can say that this is 11x cubed minus 9 times 11x cubed plus 9, okay? And that's it, all right? And so the hard part is being able to rewrite it. I think it's going from this step to this step, okay? But just take the square root of each of these terms and you're good. You're good to go, okay? Let's do another one just real quick and then we'll stop the video. And so what I want to do here is I've got 36x to the 4th minus 25. Okay, I know that if I take the square root of 36x to the 4th, okay, then that's going to give me the square root of 36 times the square root of x to the 4th. Square root of 36 is just 6, and x to the 4th is x squared, okay? And then, so this is my a value, okay? And then the next thing I want to do is take the square root of 25, and that's going to give me just 5, okay? And this is my b value. So then what I would do is I would, you know, rewrite this, okay? If I had 36x to the 4th minus 25, I'm going to rewrite that as 6x, the quantity 6x squared minus 5 squared, okay? And so then because I have these two things squared, all right, then what I end up getting in a factored form is going to be 6x minus 5 times 6x plus 5. And that's it, okay? So remember, the whole purpose of this is just a factor, okay? We just want to factor what we're doing and be able to factor these polynomials because we're going to use those concepts later to help us answer a plethora of questions. See ya. Bye.